Assalamu alaikum everyone. For last 2 to 3 days I was really sick and that is why I look really ugly. So yeah, I don't want you guys to unsubscribe to this channel after seeing my face in this condition. So back to voice. If one of your friends is pulling you from a side by one of your arms, you can safely say that he's applying some force on a collection of atoms known as U, which should cause some acceleration equal to the ratio of force to your mass in the direction of applied force. Now, if another friend of yours starts pulling your another arm, which means he's also applying some force on you at the same time, so as per my daily experiences of this physical world, I would conclude that you will be pulled towards the friend applying greater force on you. But then, what if he is applying an equal amount of force as that of your first friend? I think you will remain at the same place, though you will feel some tension in your arms. That is because the forces are equal in magnitude and opposite in direction, cancelling each other out. This is a simple case of one-dimensional equilibrium of forces, which is making you remain at your initial position, though the forces will be there and will cause some changes in your dimensions, but they will not cause any change in your position. Now, if you look at the forces working on you along the vertical axis, we will instantly think of gravitational force. And according to Newton's second law of motion, that force should also cause some acceleration. But we don't see that happening, right? Which means that there must exist some other force to counteract the gravitational force. And this force is provided by the surface you are standing on. This force is reactive in nature, which means the greater the gravitational force is, the greater this force will be. And this is why it is known as normal reaction force. This combination of forces will also cause some changes in your dimensions, but this time it is going to be compressive in nature. You might have heard the phenomenon of shortening of your height throughout the day, simply because you spend most of the daytime sitting or standing, giving this compressive force enough chance to compress the fluids between your bones, joints, or spines. It not only shortens your height, but also has some positive effects, if not many. Just because of the reactive nature of this force, you can simply apply a bit more force than you apply by default to get a bit more reaction from Earth's surface to make yourself walk, run, jump, or even play sports. Not only that, this force has also helped us exploring the universe. Rocket science. But we'll come to that later. For now, let's look at another type of reactive force known as friction, which is caused by micro irregularities of the surfaces in contact. For a simple experiment, try pulling anything right now at your table with a very little force. You will notice that despite the presence of a force, the object is not moving. In this case, the applied force is resisted by the same invisible reactive force known as friction. The frictional force, like every other reactive forces, disappears when there is no horizontal force working on the object. The frictional force have a maximum limit, which is directly proportional to the normal reaction force. We will talk about friction in detail in my next video. I think this much knowledge is enough for this topic. After knowing all of this, we can easily conclude that forces are there in action even if the object is static, only that their vector sum is zero, or in simple language, they are in equilibrium. This condition is known as static equilibrium. The image of the object along with all the forces on it without any background details is known as free body diagram. Now, let us look at this box. It is hung by 3 strings knotted at point O. If we draw free body diagram of the box, we will see that the gravitational force is balanced by induced tension in string 1. Let's say it's T1. And the free body diagram at O will look something like this. T1 will be counteracted by the components of T2 and T3 along the vertical axis, and the components of T2 and T3 along the horizontal axis will be equal and opposite in direction. So they will counteract each other, since the component of T1 along horizontal will be 0, as it is making 90-degree angle with the horizontal. If we assume the angles to be alpha, beta, and gamma between these strings, then the equation can be written as follows. And now we can tinker with these equations using some trigonometric properties, like the expansion of cos A minus B, which is cos A cos B plus sin A sin B. By this property, cos gamma minus 90 and cos beta minus 90 will be equal to sin gamma and sin beta respectively. So it can also be written like this. For equation 1, we can apply the same old rule for cos A minus B to get the values of cos 180 minus gamma and cos 180 minus beta to be minus cos gamma and minus cos beta respectively. Using the third equation, we can replace T3 in equation 1 with T2 sin gamma per sin beta. After solving this equation, we are left with T1, which is equals to minus T2 sin gamma plus beta per sin beta. After a little bit of more work, we have this. So from equation 3 and 4, we can get something which will look like this. You can remember this by the name Lamy's theorem. This is named after Bernard Lamy, or Lamy, who lived from 1640 to 1715. There is one more physical quantity which is essential to be balanced for static equilibrium to stop the object from rotating, and is known as torque. Torque is basically the tendency of a force to cause rotation. Generally denoted by tau, torque is directly proportional to the distance of the applied force from the pivot point. It is also directly proportional to the component of the force along the tangent. So torque is basically the product of the forces component along the tangent and the radial distance of it from the pivot point. It is balanced by simply applying some force on the other side of the pivot at some radial distance, such that the product of these two quantities is equal to the product of the applied force and the radial distance on the other side of the pivot. This physical quantity will cause some bending in the object, but the topic for changes in dimensions is for another day. I think that's it for today, and this video was requested by Geo Marcus. So yeah, thank you for getting involved in whatever I'm doing. See you in the next video. Don't forget to subscribe. Till then, assalamu alaikum.